Hi guys, Buildzoid here, and today we are going to be taking a look at the B550 Aorus Master from Gigabyte. So before we get into this, I do actually have a review sample of this board, so you will see me doing stuff with the board, but I'm really bad at time management, and there's Z490 and B550, and I have so much stuff to work on, and also I'm far more interested in GPUs as usual, so yeah, just don't get your hopes up about seeing this anytime soon, even though I've had the board for ages and it's just like, yeah, I'm not doing a great job. Anyway, yeah, so this is one of the most well, thank you Gigabyte for the review sample, and now back to the board. So this is one of the most expensive B550 motherboards out there. It tends to go, I think it's around $280, but don't quote me on that. It might also just get a price drop over time. And so Gigabyte decided that since this board is so expensive, what they're going to do is they're going to try and make it as similar to an X570 motherboard in terms of feature set as possible. And to that extent, they've decided that they're going to get three PCIe 4.0 M.2 slots onto this board. Now, the problem with this, because there is a problem with this, is that you don't actually have enough PCIe lanes for this, because you've got an X4 running at 3.0 going to the chipset. You've got an X4 going over to this M.2 slot, and that runs at 4.0, and that's just reserved for that M.2 slot. And then you have sort of 16x general purpose coming off of the CPU. And this 16x general purpose is what's normally meant for like GPUs, or if you have very touchy capture cards like I have, where the capture card won't run through a chipset PCIe link, then you have to connect it to the CPU. Yeah, so meant for that kind of thing. But Gigabyte decided that, hey, we have this 16x 4.0 connection. That is where we're going to grab our extra M.2 slots from. And it's like, well, yes, you can technically do that, but it has some kind of annoying consequences. So they've taken X8, and that just goes directly to your first PCIe slot, which is the normal way of doing things. A lot of like if you have a motherboard which can do X8, X8, the normal, like the first X8 is just hardwired to the primary PCIe slot. And then you'd have another group of X8 that goes into a bunch of PCIe switches. But Gigabyte decided that here they have two groups of X4 going into PCIe switches right below that primary PCIe slot. So we've got X4 and X4. And these are all 4.0, right? Because they're all from there. Or they go up to 4.0, because that's the problem with PCIe. The link speed is determined by the devices on both ends, and whichever device is slower is the one that sets the speed. So if you have a 3.0 GPU on a 4.0 motherboard, you're running 3.0. And you can't magically convert X8 into, like, these are physical lanes, so you need a lot of extra, very expensive extra circuitry to convert X8 into X16, and I've actually not seen a PCIe 4.0 to 3.0 converter. I have seen, like, on 3.0, you had 16x to 32x PCIe switches, which, like, what those would do is they wouldn't really, like, they wouldn't actually give you more bandwidth, they would just make the allocation of bandwidth more flexible. But these switches down here can't do that. These are a bit dumb, as in these just redirect the, well, they basically reconnect the lanes from one place to another. They don't actually, like, manage how much data, like, they don't allow two things to share the connection. So, anyway, so the X4s on this board go over here, and then they can either go up to the PCIe slot so that you get full X16 on that primary slot, or they can go to the M.2 slots over here. Now, the problem is you can't have X12 for your GPU. Like, PCIe works in X1, X2, X4, X8, and X16. X12 is not a thing. So as soon as, say, you install one SSD over here, and this switch redirects this, like, redirects that connection to down there, your GPU is running at X8. And if you have a PCIe 4.0 compatible GPU, like say a 5700 XT, that is not really a problem. But let's say you have a 2080 Ti or a 2080 Super. Well, now you've just lost a bit of performance. I'm not actually sure how much you lose going from X16 3.0 to X8 3.0, but yeah, you lose a bit of performance on your GPU because you've added an SSD. And it doesn't matter if you have 2 SSDs installed or 3 SSDs installed, you lose the same amount of PCIe lanes because X12 is not a thing. And also 2080 Ti's run at 3.0 and 2080 Supers run at 3.0. So this motherboard is kind of designed with like future GPUs in mind. So 5700 XTs are fine, but for NVIDIA cards, yeah, you're going to have to wait for like a 3080 or a 3090 or whatever NVIDIA decides to call their next generation. Like, you're going to have to wait for those cards before you're not going to have a potential bandwidth limit on your primary GPU PCIe slot when using the extra M.2 slots. The other issue with this is because PCIe 4.0 switches like this are rather expensive, you won't, like, these literally just go to the M.2 slots or or the primary PCIe slot. So like that's the only way they redirect. The end result of that is that these two PCIe slots down here, which you might be tempted to like stick a GPU into or something, yeah, those go through the chipset. So they're both 4.0, 4x 3.0, and they're both squished through a 4x 3.0 link that goes that way. They share bandwidth with the SATA ports, and I believe some of the USB, probably also some of the networking. So yeah, this just like in a way, this motherboard feels like to me, this kind of looks like the biggest ITX motherboard ever. You've got one actual PCIe slot, and then a lot of M.2 options, I guess. And then the other PCIe slots, like the thing is, so I've had some bad experiences with running capture cards through chipsets. I'm not sure if this is universally true for all capture cards. The capture card I have is some engineering sample thing that doesn't, like, I've never seen a retail version of it, so don't ask me how I got it. But yeah, that thing hates chipsets. If I tried to, at least AMD chipsets, I've not tried it on an Intel. Actually, I think I have run it off of an Intel chipset. It didn't have a problem with that. But AMD chipset, it absolutely bloody hates them, and it blue screens as soon as you get into Windows. With this right here, yeah, I couldn't run this board. Like, I couldn't run, like, this wouldn't work for me because it's like, oh, we have to go through the chipset. The other thing is, like, if you do have a lot of high bandwidth devices connected through the chipset, you're going to be screwed. Technically speaking, the motherboard also supports Crossfire, but running Crossfire through the chipset, like, Crossfire doesn't work great at the best of times, but when you run Crossfire through the chipset, like, that is quite an experience, and not in the good way. So, yeah, this is, like, a giant ITX board, in my opinion. Like, I think they could have honestly gone, like, full insanity with the M.2 slots and just, like, not bothered with the extra the extra PCIe slot over here, and they could have just given you another M.2 slot, like 4 M.2 slots, so that if you're, like, totally into having way too many SSDs, that you could actually use this. Because the thing is, normally B550 motherboards have a M.2 slot connected to the chipset. And I think some of them might have even 2 connected to the chipset. And then you have this board where it's like there's no M.2 slots connected to the chipset, and you just have those PCIe slots, and it's like, well, I don't know. I feel like a lot of people might just use one of the extra PCIe slots for more SSDs anyway at this point. But because there's not that many things that you would be sticking into these PCIe slots. Like, PCIe sound cards are just kind of not that great, and not a great idea. You should be using a USB DAC if you're going to be going for external, like, not onboard audio. And if you're going to be going like networking cards, you might run into a bandwidth limit depending on what kind of like if you're looking at, I'm not sure, 10 gig should still be fine unless you're also doing a bunch of like SATA access at the same time. So yeah, this is just kind of a strange board in the sort of PCIe lane allocation department. But then it also does some pretty cool things elsewhere. So let's go back to sort of where I'd normally begin, the rear I/O. So we've got 2.5 gig Realtek LAN there, which is pretty standard for B550 motherboards to have that. Then we've got Wi-Fi 6 from Intel, a Q Flash Plus button, so you can update the BIOS of the motherboard without even having a CPU installed. You can potentially... Wait, what's this? Is that just a mounting hole? Is that a clear CMOS? No, that's just a mounting hole. Yeah, this is just a mounting hole. Oh, right, yeah, so this is labeled for BIOS flashback. Yeah, okay. I was really confused by that. No, that's just some random hole in the I/O shield. But anyway, so you have QFlash Plus, allows you to update the BIOS of the board without even having a CPU installed. It also allows you to, what was it? Oh, you can potentially recover from like corrupted BIOS flashes using that button as well. So that's pretty neat. And then we've got plenty of USB ports. Like, I was a really big fan of this motherboard until I found out about the PCIe slot situation. Like, I was like, oh my god, this is like the best B550 motherboard ever. And then I heard about the M.2, like the reassigned PCIe lanes, and I was like, oh, yeah, okay. I guess I'm not like, there's no way I'd ever be able to move this into my daily system because it's just like, well, that's not gonna work. But anyway, like, it was like, I'm honestly, for my daily system, I'm not planning on staying on. Well, I'm not sure. Like, I do want to swap some parts again, but I'm not sure that I'll stay on Ryzen at this point. But anyway, let's take a look at the board. So the other reason, well, the main reason that I was like, oh my god, this board is so cool, is because it comes with a postcode. It unfortunately does not come with a power button, reset button, or more importantly, dual BIOS switches. So you're stuck with Gigabyte's automatic software dual BIOS, which, if you've ever experienced it, you know how bloody awful it is, and which is also why all the high-end Gigabyte boards will have switches so that you can manually control it, because even Gigabyte themselves acknowledge that it's absolutely atrocious. And this board doesn't have the switches, which is really disappointing, especially because they have all of this empty space right up here. And, well, down here as well. Like, they could have had the switches there or here or just like anywhere. And nope, just postcode, but none of the extra nice stuff. Then we've got basic troubleshooting LEDs over here. So basically the problem with having the dual BIOS is that you should just not be saving, like, if you're going to be saving BIOS profiles, you should just be using an extra USB stick. So essentially they've canceled one of the extra USB ports for BIOS profile saving functionality, because that's the only way to not go insane while using a automatic dual BIOS Gigabyte board. Because the problem is, every time the board fails to post too many times in a row, it'll switch which BIOS chip it's on. And technically, you can come back from the backup BIOS chip by like cutting AC power, but it's really obnoxious to like, there are ways to still tell the board which chip you want to be on even without the switches. They're just really inconvenient. And the thing is, with the switches, normally what you do is you just tell the board to stop changing which BIOS chip it's on. You put it in single BIOS mode for, like, you buy the board, you unbox it, you set it single BIOS mode, and you never look back. And you don't use the secondary BIOS until you need to. And, you know, life is so much better. But Gigabyte, for whatever reason, has the software function, like the software dual BIOS, and it's annoying and stupid, and I don't know why they do this. Like, if you look at a lot, like, the other board vendors will just give you a switch and a dumb dual BIOS implementation where it can't automatically switch on its own at all. You have to use the switch. And then there's Gigabyte where it's like, yeah, so we have this really obnoxious software system that on the high-end boards we have a workaround for with the switches. And then there's this $280 B550 board, or, well, whatever, like, expensive freaking B550 board, no switches, with the annoying dual BIOS system. So that is the other big disappointment for me with this board, is just like, oh, no switches. Okay. There's a clear CMOS jumper down here. If you want to rewire that to your reset button on your case, you can have a clear CMOS button instead of a reset button. So that's pretty cool as well. Though that's standard. It's just kind of a neat thing that you can do. So, the other thing that I got super excited about with this board is the VRM. So this right here is the exact same VRM that you would get on an X570 Aorus Extreme. Which basically means you could actually run this board naked, just like this. You could run it with no heat sinks. You could also run it without the chipset heatsink. The B550 chipset runs a lot cooler than X570 does, but anyway. So the configuration here is we've got a V-core, and that is 14 phases, and all of those phases are very real. And then we've got a SoC VRM that is a 2-phase. And so the way this is controlled is with this chip right over here, which is of course the XDPE132G5C from Infineon, which is a 14 plus 2 phase, well, up to 16 phase controller. Here it's running in 14 plus 2. In fact, it can do any assignment of phases between well, you can run it as a 16 plus 0, or you can run it as a 8 plus 8. It's perfectly fine with that. And you can, of course, not use all of the phases on any of the two outputs. So very, very flexible chip, meant for like high-end, well, I think it's meant for like GPU, well, basically AMD server CPU, like server applications, and that kind of thing. But yeah, as well as like high-end GPUs for and AI accelerators, that kind of thing. So yeah, really, really cool chip. And yeah, that allows Gigabyte to have a true 14-phase V-core along with the 2-phase SoC. And this VRM is, well, absolutely incredible in terms of, like, this is the exact same VRM that you get on the X570 Aorus Extreme, and that VRM is, like, the thing is, from my testing of X570 motherboards, they're basically all tied for, like, at the top end, they're all tied for transient response. So on B550, this might actually be one of the best performing VRMs for voltage regulation, but on X570, it's like there's other boards that do just as well. Yeah, so we've got a really, really cool controller along with the control scheme here. And then for the actual power stages, we're looking at, of course, the same Infineon TDA. Man, I've not talked about these chips in so long, I forgot what they're called. TDA 21472s. And these are 70 amp smart power stages. And they're called smart power stages because they integrate very accurate current monitoring as well as temperature monitoring, and then a bunch of safety features like over current protection, over temperature protection, and short circuit protection. So that's pretty cool. So they have a bunch of functionality that you could technically implement with external circuitry, but these have it built in, and that's why they're called smart power stages instead of just like regular power stages, which wouldn't have, like, you'd still have, say, the temperature monitoring, but you wouldn't necessarily have like OCP, OTP, short circuit protection, that kind of thing. So yeah, and also these are ridiculously efficient. So this VRM is absolutely, like, it's insane to me that Gigabyte decided to use this exact VRM on a B550 board. Which makes me all the more sad that it's like the dual BIOS is not properly controllable, and the PCIe lane assignment on this board is just kind of weird. Like, I acknowledge there are definitely some people who probably are very happy that they can have their 5700 XT and 3 PCIe 4.0 M.2 SSDs, but seems like a very niche use scenario. Because I'd assume if you're going to spend that much on M.2 SSDs, you might want something faster than a 5700 XT, just saying. But, well, this is a weird sort of workstation loadout in terms of features, but it's technically like a gaming board. And it's like, yeah, I don't get it. Like, I'm just going to stop talking about it. So, anyway, for 1.2 volts output voltage and 400 kilohertz switching frequency, this VRM is just like, so 100 amps output, this VRM is going to produce about 9 watts of heat, which is actually not peak efficiency. At 100 amps output, you'd actually want to turn off most of this VRM. Actually more than half of it, or something around half of the VRM should be turned off if you wanted peak efficiency at 100 amps output, but yeah, don't let that stop you. Because the thing is, 100 amps output, that's like a maxed out 3700X running Prime 95. Then for 150 amps output, the VRM is going to produce about 13 watts of heat. And now we're starting to actually approach peak efficiency, but we're still not there yet, because that is hit at 200 amps output and about 16 watts of heat. So what that basically means is you can literally run this VRM without a heatsink. And the board does come with a rather nice heatsink, but like, you could literally run it without it. In fact, I would have preferred if they shipped the board with nothing on it and had it cheaper, right? Just like lower the price by the cost of the VRM heatsink. but or like they could have used like the really aesthetically pleasing aluminum blocks with no surface area. They could have gone for that as well. Like it doesn't make a difference. This VRM isn't going to overheat because 200 amps is only possible with a 3950X at like ridiculous voltages, and you're going to have such a hard time cooling the CPU. So yeah, this VRM is just completely overkill for anything that you could possibly stick into an AM4 socket now or probably in the future, because I kind of doubt AMD is going to magically produce a CPU that suddenly pulls even more power than the 3950X does. Anyway, going up into sort of theoretical just for fun current ranges, 300 amps, you're going to be looking at about 24 watts of heat, so now the heatsink actually starts serving a purpose, and 400 amps output, the VRM is going to start producing about 35 watts of heat, and now the heatsink is no longer, like, you definitely need the heatsink at that point. It's just that the only way you're hitting this much current draw is if you run the CPU on, like, LN2 or something, so yeah, not really a concern. And 500 amps output, this VRM is going to produce about 47 watts of heat, which, like, it's not really practical. This VRM is completely ridiculous for this board. So, yeah, but, you know, it is one of the most expensive B550 boards, so it kind of makes sense that you'd get, well, a lot of ridiculous things, like the PCIe slot assignment, as well as the VRM. So, yeah, it's, there's nothing to complain about here with the VRM. So, yeah, but that's kind of predictable considering how much the board costs. And then the SoC just uses 2 more of those TDA 21472s. So, you know, there's no way you're going to run out of SoC power delivery, even if you were running an APU. And you technically do have an HDMI output for an APU on this, so you could mess around with that. So, yeah, for the memory power delivery, we're looking at the same single-phase memory VRM that Gigabyte's been using since, I want to say, at least Z270. And the reason why they keep using it is because DDR4 is just not that difficult to power, and there's no reason to go with anything more complex than this. So we've got a high-side MOSFET and 2 low-sides, and and those are all 4C06s, or... yeah, 4C06Ns for the entire thing. Wait, nope, 4C10Ns apparently. So they've actually cheaped out on the MOSFETs more than usual, because normally this is a 4C06N for everything, but now it's a 4C10N for everything. Not that it makes a difference, DDR4 doesn't pull that much power. What's really important is how you connect the memory to the CPU socket. And we can't see anything, because Gigabyte has a fully shielded daisy chain. You can actually see the shields more on the back of the board. It's really interesting to me. It's like they're not using the top layer of this PCB at all for the memory. Like there's just nothing here, right? Like we can see the power planes here for the various minor rails of the CPU, but then it's like you look here where you'd expect to see like ground fills over the memory, and it's just like there's nothing. So this top layer seems to be just completely empty. And this is a 6-layer PCB. But yeah, this is a very interesting layout. Like I've not seen this before. So yeah, 6-layer shielded daisy chain. Which actually, I have I wonder how the 6 layers would, so the X570 Aorus Extreme, which uses the same VRM, is an 8-layer PCB. So I'm just kind of wondering if there's maybe a slight voltage regulation difference between the 6-layer VR, like having the VRM on a 6-layer PCB and having the VRM on an 8-layer PCB. Because technically on an 8-layer, you could have a more substantial power plane. But this might be something I look into testing. At the same time, I think that probably makes such a small difference, it doesn't even matter. That's what I expect. Like, I expect to measure it, and it'll be just, like, the same. It'll be, like, it'll be less than what my oscilloscope is able to measure. And so I'll just be like, yep, they perform the same. Anyway, shielded daisy chain. And what the daisy chain means is obviously the primary, well, the first memory slots you should be using are these two. And so Gigabyte, like the thing is, this is a new memory, like this is the sort of newest memory topology that Gigabyte has for AM4 CPUs. And so the thing I'm most excited to mess around with on this board is actually memory overclocking, because it's not like I can run a multi-GPU setup on it. And so, yeah, I really want to try do like well, I want to try beat my 5.1 gigahertz max memory clock record that like my current memory clock record that I have. I want to try beat it with this board. Um, and it'll be just interesting because I'll still be using the same 3700X I used for the first, for the first, like the 5.1 gigahertz attempt. So if this does 5.2 with the same CPU, that'll be impressive because it would be beating a 2DIMM ITX board. Um, and yeah, so Gigabyte has some big claims for max memory speed capabilities out of this board. But the thing is, for day-to-day performance, the only thing that really matters is being able to go up to like 3800 megahertz because Ryzen third gen's I/O die is not able to run the FCLK above like 1900 megahertz. So there's no point trying to really push past that. Um, and that goes, and so basically, and that's the reason why the daisy chain is perfectly fine, because even if you're running 4 memory sticks, you're not going to have a problem because 4 memory sticks, if you're running 4 memory sticks, you're going for daily usage. And well, you're not going to be going outside of the FCLK like outside of one-to-one FCLK to MCLK. And so there's no reason to go above 3800, and you're not going to have a problem going up to 3800 on a 6-layer shielded daisy chain topology. That's just not going to be an issue. So yeah, the memory setup right here is perfectly good. And I should have shown actually I did show the back of the board a little bit. What's kind of interesting is we do actually have kind of a lot of the SoC VRM is entirely filtered with SMD aluminum polymer capacitors. So these are all from APAC. Whereas the VCore VRM gets this one up here, but I don't think that's done for like better transient response. I just think they ran out of space for the regular through-hole ones, so they squeezed one up here. It was like, yep, now we've reached the bulk capacitance requirements for the VRM, because otherwise you'd be actually trying to move this closer to the CPU socket. If you actually wanted to use that to improve transient response and weren't just trying to reach the design requirement for bulk capacitance to suppress overshoot, which technically is part of the transient response, but it's just like for overclocking, the thing that makes your overclocking worse is the undershoot. The overshoot is kind of like, yeah, it looks ugly, but not really that big a deal unless it's causing instability in the unless it's causing the voltage controller to overreact, and that can lead to some voltage regulation instability as well. So anyway, yeah, SoC is entirely filtered with aluminum polymers, which could also give a benefit to the memory overclocking as well, because the memory controller runs off of the SoC, so SoC voltage, and then all of the I/O die voltage, like this, what's it called, VDDG rails are converted down from SoC. So having a more better regulated SoC power delivery might actually help with FCLK stability a little bit, but I wonder about that. Because the thing is, it's also a very low current rail, and it doesn't really, because it's low current, it's not like you have massive current spikes going, occurring on that rail. Just relatively speaking, compared to something like VCore, where you can have the CPU go from, pulling 200 amps to pulling 50 or 10. Which of course the VRM has a much harder time dealing with than if you're going between 10 and 20 amps as the SoC goes from idle to load. But yeah, so that'll be that might be interesting. That might have some benefits. For all of the bulk capacitors, we're just looking at Nichicon FP series capacitors rated for 10,000 hours at 105 degrees. And yeah, that's also, we have those on the input filter and of course the output filter as well. So those are pretty standard. We've seen them on Gigabyte, all Gigabyte motherboards ever, or well, high-end Gigabyte motherboards recently. So yeah, that's pretty much it for this board. It's not really that much, we've got a hell of a lot of VRM. We have a postcode, which is good. There's dual BIOS, but there's no switches for that, which is bad. There's, you've got the 2.5 gig LAN, you've got Wi-Fi 6. I'm not sure. Overall, this board just, I guess if you really want 3 M.2 PCIe 4.0 SSDs, that's kind of the main thing that's a highlight with this board. And the memory overclocking on this should be very good, but I'm pretty sure Gigabyte has a bunch of other 6-layer B550 boards, which will use the exact same memory topology. And, well, the power delivery might be, like, the SoC power delivery will be slightly different on those, but probably not significantly worse. And so it's just like, is that really gonna matter? But probably not. Um, so yeah, I wouldn't really be buying this, like, I think the reason you'd be buying this is the M.2 slots. I wouldn't be buying this for the VRM, because, like, the VRM is incredibly overkill, but there's a lot of boards with good VRMs for B550. That's, like, this is probably one of the best VRMs on B550, but in the grand scheme of things, it's not like it's going to make it's not, well, it might make the difference between running 4.3 gigahertz and 4.325, right? Which is like, that's not actually that big a deal, so who cares? So yeah, I'm really like, I don't like the M.2 thing that Gigabyte has done. Like, I like having PCIe slots with PCIe lanes that come from the CPU, and, well, this board's just not really for me because of that. And then also the dual BIOS without the switches is just an incredibly annoying thing to put on a motherboard. Like, it is so obnoxious that, in fact, like, it's really surprising. Like, if you want a better low-end Gigabyte overclocking experience, you end up with, like, the really cheap boards actually being easiest to work with because they're single BIOS. And it's just like, why does such an expensive board have dual BIOS? Oh, I guess also, before I end this, I should mention the extra 4-pin is completely unnecessary, because even if you have a 3950X, you're not getting more than 300 watts through that single 8-pin. As in, you're not pulling more than 300 watts through that single 8-pin, and that's well within spec for that power connector. Unless, of course, you fail to plug it in correctly, in which case that's not the power connector's fault, that's a user error fault, and, like, you'd be liable to not plug in the 4-pin correctly either. So, yeah. Anyway, that is the B550 Aorus Master. Yeah, that's it. That's it for the video. So I guess thanks for watching. Like, share, subscribe. Thank you to Gigabyte for sending the board over. I really hope it does well on memory, because as far as the actual sort of rest of it, I'm not... Actually, man, memory overclocking on dual BIOS. Oh my god. I'm gonna hate myself. Like, that is going to be so incredibly obnoxious. If I figure out a way to just... I'm gonna manually... Like, yeah, I'm gonna add BIOS switches to this board. I am not dealing with dual BIOS. I'm not... Just, no. I will figure out a way to mod this board into not having automatic dual BIOS, because it is so incredibly obnoxious that, yeah. So, there, that's the other thing I'll be doing. I'll be fixing Gigabyte's board for them. Anyway, yeah, that's it for the video. So, I've already gone through all of the usual outro. So, if you'd like to support what I do at the channel, I have a Patreon. There's a link down in the description below to that, where you can support me directly. And then there's also the AHOC Teespring store, where you can pick up shirts, stickers, posters, the usual YouTuber merch. And there's a link to that down in the description below as well. So, yeah, that is it for the video. Thanks for watching, and goodbye.